Alright, we're going to start with the unit circle because it's essential in all trigonometric functions. I will teach you guys what the unit circle is and how to use it. I'm going to cover the core principles of the unit circle because it's essential when it comes to pretty much all trigonometric functions. So, what is the unit circle? Let's draw one here for a second. All you have to do is to draw a circle, just like that, and then it crosses like that, and that's the unit circle. Now why is it called a unit circle? Well, it's because this right here on the x-axis is 1. This on the y-axis is 1. This is 1. So this is 1 and this is 1. What does that mean? That means that the radius of the whole function is 1. That's what unit stands for. If you have a line and you ask how long is it and you want to use units, if we define this length right here to be 1 meter, then basically divide all this in 1 meters. And this is units because we'd have split this up into unities. This is 1 unity, this is 1 unity, and this is 1 unity. The same thing applies for the unit circle. It has a radius of 1. Now why is this important? Well, for starters, we're gonna see how sine and cosine applies to this circle. Let's draw an angle with a certain degree. So let's draw an angle. One thing you have to remember with the unit circle is that the base of the angle is always the x-axis. Now this is the base. Always, always, always. This is the base. And this is the angle. Let's call it theta. So now, the sine of theta. This is opposite, which is this side, over hypotenuse, which is this side right here. So this is the hypotenuse, and this is the opposite. So it's opposite over hypotenuse. The hypotenuse in this case is the radius, which is 1. So it's opposite. It's opposite. Why? Well, sine of theta is equal to op over 1, which is the same thing as opposite. So sine of this angle is this length. This length you're seeing right here is sine. Now what is cosine in this angle? Well, it's adjacent, which is this side, divided by hypotenuse. And remember again, the hypotenuse is the radius, which is equal to 1. So thereby, this is equal to the cosine of theta, because it's equal to adjacent over 1. So it's adjacent. Now we can draw any angle we want to, as long as you remember the normal coordinate system. Well, this is positive and this is negative. This is positive and this is negative. So for example, if we have one angle that goes like this, and here's the angle, it's like this, this is the angle. Let's erase some of this stuff. Now this is our angle. Now the sine in this case is this length right here. It's this length right here. Or you could basically draw it right here and it's this length right here. It's this length. It's this length. So the cosine in this case is this length right here. So is the cosine positive or is it negative? The cosine in this length in this case is negative. Why? Because it goes in this direction. If we had a coordinate system, like with a y and an x, and you plotted a dot right here, right there, the coordinates of this dot would be in the y-axis, it will be positive, and in the x-axis, it will be negative. That's why cosine is negative. And you can actually see this fit into the sine function. We'll go into that in more detail later. But the essence of the unit circle is that it's supposed to be a representation of sine and cosine. Now let's have a look at one special case of the unit circle. Let's draw a new one. This is getting kind of messy. So we start off by always drawing a circle first. Why? Because if you draw the coordinate system, it will be very hard to adjust the circle unless you're really good at drawing circles. So let's draw an angle of 0 degrees. This is our line. This is our line of 0 degrees. There's no degrees here. Now, the sine of theta, or the sine of 0 degrees, this is 0, is equal to, well, if we go back to our triangle trigonometry with the SOHCAHTOA, we have a right triangle. This angle can never be 0 degrees, because then it will be a straight line. So therefore, the unit circle is special because it enables us to actually take the sine of 0 degrees. Now think about it. We define this side to be cosine. Then we define this axis to be sine. So this is a unit circle, which means that this coordinate is 1. This coordinate is 1. This coordinate is 1. This coordinate is -1. This coordinate is -1. So since sine of 0, it's 1. You could actually type that into a calculator and you will find that the sine of 0 is 1. I'm sorry, the cosine of 0 is 1 because this is the cosine. This is the cosine. And since it extends all the way to 1, its cosine of 0 is equal to 1. And what's the sine of 0? What is the height? What is the height? What is this point along the y-axis? It's non-existent. It's 0. That's why the sine of 0. The sine of 0 is equal to 0. You can actually type that into a calculator and you will see the answer. Now let's pretend this angle isn't there, and let's draw another angle which goes like this. Now this is a new angle. It's this angle right here. Now here's a certain angle, and this angle is 90 degrees. This angle is 90 degrees. So what is the sine of 90 degrees? Well, it's this portion right here. How long is this? Well, it's 1. So sine of 90 is equal to 1. How about the cosine? How much in the x-axis is this point right here? Well, it's 0. Cosine of 90 degrees is equal to 0. We could draw a angle this way. Remember, we always start at the base. This is the base. So basically draw an angle right here, and this angle has a sine which is negative because it goes down. Guys, you see this point? It goes down. Let's look at the y-coordinate. In this case, the sine, it's the y-coordinate. So it goes down. Therefore, the sine is negative, and the cosine is also negative because it goes in this direction. The sine goes down, it doesn't go up, it goes down. That's why the sine over here is negative, and the cosine is also negative. It's kind of funny. However, we will go into more detail on remembering certain radians and also certain trigonometric identities, which we'll later cover and use properly. Thank you for watching, and watch my other videos.